Hi, I'm Christina, and today I will be presenting to you about the impact of rainfall, fertilizer use, and sustainable practice on ratio crop yield in smallholder farm. For introduction, smallholder farmers play a key role in food security, but their productivity is often limited by rainfall variability, poor soil fertility, and resource constraints. Fertilizer use can improve yields, yet farmers struggle with issues of cost, access, and proper application, which can either reduce efficiency or harm the environment. At the same time, sustainable practice like crop rotation, mulching, and agroforestry help improve soil health and resilience to climate stress. This study explores how rainfall, fertilizer use, and sustainable practice influence crop yields, with the aim of supporting more resilient and sustainable farming system. Our objective is to analyze the relationship between rainfall variability and crop yield in smallholder farms. Second, to evaluate the effects of fertilizer use, such as types, rates, and timing, on crop yield performance. Third, to determine the influence of sustainable agricultural practice on soil health, resource use efficiency, and crop yield. And lastly, to identify the combined and interactive impacts of rainfall, fertilizer management, and sustainable practice on crop productivity. For methodology under data description, we have 4 types, which the first one is population. The population of the studies consists of smallholder farmers cultivating crops under rainfed conditions. Second is samples. The sample include 120 smallholder farms for which data on rainfall, fertilizer use, sustainable practice, soil health, and crop yield were collected and analyzed. The third one is data collection method. The data for this study is secondary data generated for research purpose. It combines realistic agricultural variables such as rainfall, fertilizer, sustainable practice, and yield into a dataset designed to reflect smallholder farming conditions. And the last one is sampling technique. Since the study relies on prepared secondary data, no random sampling technique was applied.
For variables, the first objective is to determine the relationship between farm size, rainfall, fertilizer use, and crop yield. The variable that we use is rainfall and crop yield. Type of variable is quantitative continuous and quantitative continuous. Type of measurement scale is ratio scale. And the method that we use is regression. The second one is to examine the strength and direction of the association between sustainable practice, type, and soil index health. The variable that we use is sustainable practice type and soil health index. Type of variable is quantitative continuous for both of them, and type of measurement scale is ratio scale, and the method that we use is correlation. The third one is to describe the distribution of crop yield and fertilizer application among farmers. Variable that we use is crop yield and fertilizer. Type of variable is quantitative continuous. Type of measurement scale is ratio scale, and the method that we use is histogram. And the last one is to assess the normality and asymmetry in the distribution of crop yield. Variable is crop yield, and type of variable is quantitative continuous. Type of measurement scale is ratio scale, and the method that we use is QNIS.
Next, we are going to talking about variables. First, histogram, and second, scatter plot. First, we have the histogram. This histogram shows crop yields are roughly normal, centered around 1,200 kg. The mean is 1,219.67 kg, with a standard deviation of 201.39, indicating moderate variability. Most yields fall between 1,000 to 1,400 kg, with few outliers below 800 or above 1,600. Overall, productivity is stable, though low yields may need attention. However, for the second one, which is the scatter plot, shows a positive link between rainfall and crop yield, with most points between 400 to 800 mm rainfall and 1,000 to 1,500 kg yield. Moderate rainfall appears optimal, though yields vary within similar rainfall levels, suggesting other factors also affect productivity. A few outliers exist, but overall rainfall supports higher yields without being the only determinant. Next, for the frequency table, descriptive statistics show crop yields averages 1,219.67 kg, ranging 592 to 1,681.2, with a near normal distribution. Rainfall averages 603.35 mm, ranging 104.8 to 1,011.8, with slight left skew. Fertilizer use averages 118.18 kg, ranging 23.0 to 230.3, showing low variability and near symmetry. Overall, yields and rainfall vary moderately, while fertilizer use is more consistent. For numerical graphic, there are two, which is mean and median. We're going to talk about mean first. Mean is defined as the average or a set of two or more numbers that can be computed with the arithmetic mean or the geometric mean method. Mean can be used to calculate several types of data, such as mean for ungrouped data and mean for grouped data. As for median, median is known as the midpoint of the data set or the center value. This will determine the value of the upper half and lower half. To find the ungrouped median, the data should be arranged ascending order of the data. For all data, the mean is the center of the data that had been arranged. For every data, there will be require a simple calculation to get the values. We need to find two data in the center and divide both by 2. Mode is the value that have high frequent data. The highest value that appears in dataset. A data also can have more than one mode. Coefficient of determination is to measure the proportion of variation in dependent variable y that can be explained by independent variable x. It also measures the strength of the linear relationship, which in this case is crop yield and rainfall, also fertilizer. And variance is the measure of average difference between each point from the mean. Standard deviation is value indicates how closely a dataset's values are dispersed around the mean. The Pearson coefficient are to determine or measure the shape of distribution, while Pearson's product moment correlation coefficient is a measurement of the strength and direction of the relationship between two variables on at least an interval scale. While regression line, in every set of data, a regression line shows the relationship between scattered data points. When there is a linear pattern, it indicates the relationship between the dependent variable and the independent variables, where independent variables are rainfall and fertilizer, while the dependent variable is the crop yield. Regression lines are the methods that we use to find the best fit lines. A line with a positive slope expresses that there is a relationship between the independent and dependent variables. The equation that is used to calculate the regression line is y equals ax plus b. As for result and interpretation, data presentation. The table shows data from 20 farms on rainfall, fertilizer use, and crop yield. It allows easy comparison of how differences in rainfall and fertilizer application affect productivity across farms. The picture shown in the slide is box and whisker plot. The box plot compares crop yields for farms with and without sustainable practices. Farms using sustainable practices have a slightly higher median yield and more consistent results, while those without slow, wider variability and several low yield outliers. Overall, sustainable practices appear linked to more stable and slightly better yields.
Histogram for both variables. The first histogram is about rainfall. The histogram displays the distribution of rainfall across 200 observations. The data shows a roughly normal distribution centered around the mean rainfall of 603.95 mm with a standard deviation of 147.36 mm. Most values are concentrated between 500 mm and 700 mm, with the highest frequency occurring slightly above 600 mm, indicating that this is the most common range of rainfall. The distribution tails off on both sides, with fewer observations receiving either very low, which is below 300 mm, or very high, above 900 mm rainfall. This suggests that rainfall levels are generally moderate across the sample, with only a few extreme cases. For the second histogram, it is for fertilizer. The histogram shows the distribution of fertilizer application, kilogram per hectare, among 200 observations. The data is moderately symmetric, with a slight right skew, and centers around the mean of 118.18 kilograms, with a standard deviation of 49.64 kilogram. Most farmers applied between 19 and 150 kg, with a peak frequency occurring just above 120 kg. There are also notable frequencies at higher values, for example 180 until 200 kg, though fewer farmers use extreme amounts beyond 200. Correlation and regression analysis. Okay, this is a scatter plot. The scatter plot illustrates the relationship between rainfall and crop yield, showing a generally positive trend. As rainfall increases, crop yield also tends to rise, suggesting a moderate positive correlation between the two variables. However, the data points are widely scattered, indicating that rainfall alone does not fully explain variations in crop yield. While higher rainfall is generally associated with better yields, other factors such as soil quality, farming practices, or fertilizer use may also significantly influence productivity. Overall, the plot suggests a positive but not a very strong linear relationship, highlighting the need for further analysis to better understand the factors affecting crop yield. The multiple regression model explains 36.1% of variance in crop yield, as indicated by the R-square value of 0.361. This suggests that rainfall and fertilizer use together account for just over one-third of the variation in crop yield across the sample. The adjusted R-squared of 0.354 shows a slight correction for the number of predictors in the model and indicates that the model remains a good fit. The standard error of the estimate is 161.85, which reflects the average distance between the observed crop yields and the predicted values. The F statistic is 55.560 with 2 and 197 degrees of freedom, and the associated p-value is less than 0.001, indicating that the overall model is statistically significant. In other words, rainfall and fertilizer used together significantly predict crop yield. Coefficient table. The regression coefficient shows that both rainfall and fertilizer use are significant positive predictors of crop yield. The unstandardized coefficient for rainfall is 0.751, meaning that for every additional millimeter of rainfall, the crop yield is expected to increase by 0.751 kg per hectare, holding fertilizer constant. Similarly, the unstandardized coefficient for fertilizer use is 1.0121, indicating that for every additional kilogram of fertilizer applied per hectare, the crop yield increases by 1.121 kilogram per hectare, assuming rainfall remains constant. Both predictors have p-values less than 0.001, confirming that their effects are statistically significant. In terms of relative importance, the standardized beta coefficient shows that rainfall, which is 0.549, has a stronger impact on crop yield than fertilizer use, which is 0.276. Additionally, the VIF, variance inflation factor, values for both variables are very close to 1, indicating no multi-collinearity issues. The predictors are not strongly correlated with each other. Prediction. An example of prediction using the regression equation can be calculated as below. Crop yield equals to A plus B1, which is rainfall, plus B2, which is fertilizer, where A is intercept constant, B1 is coefficient for rainfall, B2 is coefficient for fertilizer used. Based on the estimated coefficient, A is 500, B1 is 2.1, and B2 is 4.8, the equation becomes crop yield equals to 500 plus 2.1 plus 4.8. To illustrate, for a farm receiving 600 mm of rainfall and applying 12 kg per hectare of fertilizer, the predicted yield is crop yield plus 500 plus 2.1 times 600 plus 4.8 times 120. Crop yield is equal to 2,336 kilogram per hectare. This means the model predicts that under these conditions, the farm would produce approximately 2,336 kilogram per hectare of crop yield. The regression equation can therefore be used to estimate expected yields value for different combinations of rainfall and fertilizer use, providing useful guidance for farm management and decisions.
In conclusion, the study investigated the impact of rainfall, fertilizer use, and sustainable agricultural practice on crop yield in smallholder farms using secondary data. The analysis, which applied descriptive statistics, histograms, scatter plots, box plots, correlation, and regression, found that crop yield was positively influenced by all three factors. Fertilizer application rate and soil health index emerged as the strongest predictors of yield, while sustainable practice supported productivity indirectly by improving soil quality, and rainfall showed a moderate effect with yields peaking at optimal levels. The model explained about half of the variation in yield, indicating that other factors such as pests, crop variety, and market conditions may also play a role, although the finding highlight the importance of combining fertilizer management with sustainable practice to strengthen resilience under variable rainfall. The study was limited by its reliance on synthetic data and future research using real multi-season field data. For recommendation, based on the findings, several recommendations can be made to improve crop yield in smallholder farms. Fertilizer application was shown to be one of the strongest factors influencing productivity. Therefore, farmers should be encouraged to apply fertilizers at appropriate rates and timings to maximize efficiency while avoiding overuse that may damage soil health and increase costs. Sustainable practices such as mulching, crop rotation, composting, and agroforestry were also associated with higher yields, indicating the need for greater adoption of these methods to enhance soil quality and resilience under variable rainfall conditions. In addition, strengthening soil health management through organic amendments and better monitoring will further improve fertilizer effectiveness and long-term productivity. Since rainfall remains an uncontrollable but critical factor, water conservation strategies such as rainwater harvesting and improved drainage system should be promoted to reduce risks from the drought or excessive rainfall. Finally, as the study relied on synthetic secondary data, future research using real multi-season field data is recommended to validate the results and capture other important factors such as pest, crop variety, and farmer knowledge.